Alright guys, today's lesson is about sequences and series. Now we've learned about sequences before. We actually did that back in geometry and touched on it in Algebra 1 also. But like sequences is just where you have a pattern with numbers, right? And there are two main kinds of sequences, just as a refresher. Okay, now I know this is spelled arithmetic, but we call it an arithmetic sequence. And that's whenever you're adding the same thing every time, right? We learned this back in Algebra 1. And so like an example of an arithmetic sequence would be like, let's just do different. Let's do 8, 16, 24, 32, right? So that's an arithmetic sequence because I'm adding 8 every time. This would be the first term. We call it a sub 1. And then we say the common difference, or D, is 8 because that's what you're adding each time. Each one of the terms is like it's a term. So like that's A1, this would be A2, and so on, right? And so again, we learned that back. It's been a while, but we learned it. What's new this year is that you need to know what a series is. Okay, so what a series is whenever you take these terms and you add them together, or you find the sum of them. So there is this thing called summation notation, and it uses the capital Greek letter sigma. Now I know it looks like the letter E. I'm very well aware of that. But it's the capital Greek letter sigma. The lowercase Greek letter sigma is very different meaning in math. But if you see this big E in math, you know you're going to be adding something up. It's if you've ever used Sheets or Google Form or Google Sheets. Sorry, my brain's not on. Or Microsoft Excel, and you see this button that has the symbol on it, you know you're adding. Okay, so here's what you need to know as far as the basics go, and then we're going to find the sum of that arithmetic sequence that we just wrote down. First of all, you're going to have like the sequence of whatever is going to be back here. Like it'll be in formula form or something like that. And on the bottom, it'll say, okay, you need to start with the first term or the second term or the 8th term. The top number will tell you which number term to stop at. So like maybe I only want the sum of the first 10 terms, the top number would be a 10. Okay, so that's what it's called summation notation. Summation notation. All right. So if I wanted to find the sum of the arithmetic sequence, like let's just do this one for example. This is a good example, the one that we have up here. And let me choose a not similar color. So I'm going to start with an easy one. Say, what if I said, okay, I want to start with the first term, and I want to go to the 5th term of this sequence. So in parentheses, it would have 8 plus 16 plus 24 plus ... right? So that's one of the ways you can see that. Sometimes they'll actually put the sum after it like that. So all that means is that's exactly what I'm going to do. I'm going to add 8 plus 16 plus 24 plus 32 plus 40, and I know that's where I'm going to stop, right? Because that's what these numbers right here mean. This means, oops, I forgot my equal sign right there. This means I'm going to start at the first term, which is 8, and I'm going to stop at the fifth term, which is 40, right? 1, 2, 3, 4, 5, and I'm just going to add them all up. Right, I do not know what that is added up. I'm going to let you guys do that because I don't have a calculator in front of my face. But that's what you're going to do. You're just going to add those up, and that would be the sum. Now that's all fine and dandy and wonderful and great if it's only just like a few terms, right? But what if it was a lot of terms? What if it was the first 20 terms? Right, we all know me. I'm going to add them wrong. I'm going to accidentally skip one. I don't want to write down 20 numbers. So, of course, there is a formula for the sum of an arithmetic sequence. Now, obviously, I'm not going to make you memorize this, especially at this point. But I just want to make sure you're getting comfortable with it. It's pretty simple.
Please excuse the interruption.
All right, so one of the ways we can see this sum is like this. We're going to do n times a1 plus an divided by 2. Again, this is the sum. Or, and this is really the same formula, it's just been kind of tweaked a little bit. N over 2 times 2 times the first term plus n minus 1 times the common difference. So depending on what you're given, one of them is going to be easier or more useful than the other one. So let's do a quick one for this one. Let me find a good one. Okay, like this is okay. This is a good one. What if I said find the sum of, the first 80 numbers? So 1, 2, 3, 4, all the way to 80. If I added up all the numbers from 1 to 80, what would it be? Now, I would not want to use this first formula because what you need is, my highlighter, is you have to know what, well, I guess we can use this one because we do know the last term. Let me shut up and go back. Or maybe we don't know how many terms, right? Well, of course we do on this one. There are 80, right? So this first formula will work fine. I don't know what my brain is thinking today. Let's just do this problem, shall we? So again, I'm using this first formula right here. The sum of the first, and there are 80 terms, right, going from 1 to 80, literally counting 1 to 80. So the sum of the first 80 terms is 80, right, that's the number of terms, times the first term is obviously 1, the last term is 80, and then I'm going to divide by 2. And that would give me the sum of the first 80 terms. Okay. Now, if I wanted to do, I was trying to find one where we didn't know. Okay, so here we go. Here's a good one. So this is the same thing. So maybe my, I just put my eyeballs on it. Where'd it go? Okay. So say it's 2, 5, 8, and so on. And I want to find the sum of the first 15 terms. Okay, so this time I don't know what the 15th term is, right? They'd say, hey, find the sum of the first 15 terms of this sequence. That's whenever I'm going to want to use the second formula because I don't know the 15th term, so I couldn't plug it in right here, and it's just not going to be very nice, right? So if I were to do that, now I know I'm obviously adding 3 here, right? I can see that. I can see that my first term is 2, and I know that I'm finding the sum of the first 15 terms. So using that second formula up there, so the sum of the first 15 terms is 15 divided by 2, 2 times 2, because 2 is my first term, plus 15 minus 1. And then again comes the common difference, which is what we're adding, is 3. And you work that out, and that will give you the sum of the first 15 terms. Okay, so that is an arithmetic sequence, right? We know the sequence is when you're just adding the same thing every time. And to add it up, again, using summation, we can use either of those two formulas, again, based on what it is they give me. All right, now there is actually a second kind of sequence that we learned back in algebra is when we focused on this one. This is a geometric sequence. So a geometric sequence is whenever you're multiplying times the same thing every time. Like if I had 3, 6, 12, my brain just turned off, wow, 24, 48, right? So I am multiplying by 2, right? So this will be a geometric sequence. Now in geometric sequences, we don't have a common difference because we're not adding or subtracting, but we have what's called a common ratio, or what it is we're multiplying by. So in this case, the common ratio, of course, would be 2, because I can see if I do 3 times 2, 6 times 2, 12 times 2, that's going to give me the next term in the sequence. So that was the other one we learned about. We talked about if we graph these, then it's going to be an exponential function, which means that these numbers are going to get really, really big, really, really fast. Now, just like arithmetic sequences, we have geometric series. Okay, so a geometric series also has a fun little formula. Let me write it down because I never can remember it. So again, we're gonna add it up. So here's the formula for the geometric series. So the sum is equal to the first term times 1 minus the common ratio to the nth power, all divided by 1 minus the common ratio. Okay, so that's the sum if it's a geometric sequence. So like, say maybe I want to do this one, and I want to find the sum of the first 12 terms or something like that. So I want to find the sum of the first 12 terms. My first term is obviously 3. My common ratio is 2. And again, I'm finding the first 12 terms, so it would be to the 12th power over 1 minus 2. You will end up with large numbers on here. Notice I'm raising that 2 to the 12th power. That's going to be pretty big. Think about what if your common ratio was like 5 or 12 or something like that. Those are going to get really large really fast because it is geometric. You're multiplying this time instead of adding. But the concept is pretty easy, right? We're just going to take that pattern that we know that's happening and go, hey, here's a shortcut for adding all of these up. And again, this formula right here is the shortcut. It's pretty straightforward. It's not anything like too terribly crazy. But let's look at what happens if we have something called an infinite series. I remember being in high school and learning these, and I don't know why this just absolutely blew my mind. I was still wrapping my head around the concept of infinity. So an infinite series. So all of that we've done so far have been finite series, right? Finite is the word I just said. Finite means it ends, right? We are finite beings. We're gonna die one day, right? Our groceries in our cabinet, they're finite. They're gonna have an end, and that's what happened here, right? Like, because I only did the first 5 terms here, and right here I did the first 80 terms, and this one I did 15 terms, so I stopped. Now, theoretically, I could keep going forever, right? And that's what an infinite series is. An infinite series is a series that does indeed go on forever. Well, the coolest thing happens with an infinite geometric series if your common ratio happens to be less than 1. It's really cool. So let me write all this down. So we have the sum of a geometric series. So we say that's a times r to the k minus 1, right? That's the formula for a geometric series where k starts at 1, right, first term, but instead of having a stopping point, it goes on to infinity. So technically, I'm going to add up every term in this geometric sequence, but the stipulation is the absolute value of your common ratio, or it has to be a positive number, is less than 1. So we're talking decimals or fractions or something. You're multiplying by a small number, and instead of the series going up, what's going to happen is it's going to go down. That's exactly what happens. So an example, not a good example. Oh, here's a great one. Excuse me. So like if I said, find the sum from 1 to infinity of this geometric sequence that is defined by 3 times 0.75 to the k minus 1 power. Okay, I probably should have went back over this, and I forgot, because it has been a while since we've talked about geometric sequences and series. This number is always going to be your first term And this number, as we can see it right here, is your common ratio. So we can see that your common ratio is definitely less than 1, right? 0.75. So if I want to add up all of the numbers, starting at 3 and multiplying by 0.75 every time, what's going to happen is obviously the numbers are going to get smaller and smaller and smaller and smaller. And it does what we call convergence. Converges. Right? It's called a convergent series if you want to be really technical. And that just means it actually has a stopping point. The formula is really, really simple. All it is, and probably should have written it up here, huh? It's A over your first term over 1 minus R. Like that's it. That's the whole formula for this thing. So it's just going to be 3 over 1 minus 0.75. And again, my brain just like imploded from this. The answer to this one's 12, for example. I can do that in my head real quick. It's just 12. So if I were to add up every single number starting with 3, right? So this, if I wrote out the sequence, for example, right, my first term would be 3, and then the next one would be 3 times points. I'm going to have to do it in fractions, guys. Sorry, my brain doesn't work that way. 9/4, and then the next one will be like 27/16, and then the next one, like, it's going to keep getting smaller and smaller and smaller. That's what's happening here. All right, so if I added all those up to infinity, like the infinite number, the answer is 12. It's 12. Which again still kind of blows my mind as an adult person that has a degree in mathematics, and it's just the coolest thing ever, because I'm a huge nerd. But just letting you know that that's what an infinite. Now we don't have that for arithmetic. Okay, we don't have that for arithmetic, but we do have it for geometric. So you need to know how to find the convergence of the series, is what it's called. All right, so in a hugely little nutshell, arithmetic sequences and series and geometric sequences and series.